What's up, everybody? This is Danny Mathematics again, here to explore another example. And today, guys, I want to go over example 5 and example 6 of projectile motion. Example 5 and example 6 of projectile motion. Let's go ahead and start off with example 5. Example 5, guys, it says Jackie is standing 25 feet above the pool. Okay? She jumps off the diving board with an initial velocity of 10 feet per second. Okay, and as you can see, guys, I have a little illustration where this is the pool, the x-axis is the pool. Of course, she's 25 feet above the pool, and of course, below the pool is all the water, right? How deep you can go in the pool, right? So her motion, or her projectile motion, as she jumps off the diving board is represented in this equation where h of t, or the height, is equal to negative 16t squared plus 10t plus 25. And of course, guys, t is time, which is represented in seconds, right? So the question that they're asking, guys, is what is Jackie's height after 2 seconds? Okay, it's pretty easy. All we need to do, guys, is we need to set the time, which is t, to equal to 2 seconds. So we're gonna put t equals 2. That's what we're gonna put, t equals 2. All right, and then all we need to do, guys, is plug t equals 2, right? We're gonna plug t equals 2, right, into the equation. So that's all we gotta do, guys. And then once we do that, we can solve for the height. How high, right, or how low will she be, either above the pool or actually in the water, diving into the water, okay? So once again, we're gonna plug t equals 2 into this equation. So let's go ahead and do that. So once again, I got the height, or h of x, h of t, my bad. H of t, which is the height, equals negative 16 t squared, right? So that's gonna be negative 16 times 2 squared. Okay, plus 10t, which is going to be plus 10 times 2. Okay, and then plus the 25, and we know that the 25 is the y-intercept because in the problem she was standing 25 feet above the pool, which is the diving board, right? So we know that's the y-intercept. So it's going to be plus 25. All right, so guys, either you can use a calculator or you can do it by hand, okay? Once again, I've done this problem before. So once again, I know that 2 squared is actually 4, right? And then negative 16 times 4 is a negative 64. Okay, which is a negative 64, okay? Of course, guys, we know that 10 times 2 is 20, so it's going to be negative 64 plus 20, okay, plus this 25, right? We're going to bring down that 25. Okay, so negative 64 plus 20 is negative 44, and negative 44 plus 25 is negative 19, okay? Which means that after 2 seconds, as she dives, right, the impact was so strong to where now she's actually 19 feet below the pool, okay? So she's actually negative 19 feet, or 19 feet below the pool, right? The water of the pool, right? Or the surface of the pool. Okay, so I'm gonna put below surface. All right, and remember, guys, this is at 2 seconds. So when I graph this, I'm gonna go to the x-axis, which represents the time, which is 2 seconds. And I'm gonna go all the way down because remember, it's negative 19, meaning that she already dived in the pool and she was still diving down as she was going through the water, right? So that's about This is negative 20, so it's a little bit above negative 20 at 2 seconds. That's about right here. So that's what she would be at 2 seconds. So if I was to create a projectile motion, just representing that, okay, she hits the water, probably somewhere in between 1 and 2 seconds. Then right at 2 seconds, she's at 19 feet below the surface. 19 feet below, which is negative 19. Okay? So that will be her position at 2 seconds, guys, after she jumped off of the diving board. Okay? So this is our answer, guys, at 2 seconds. At t equals 2 seconds. So this is our answer. Negative 19 feet, or you could say 19 feet below the surface at 2 seconds. Okay? That is our answer. Now let's go to the second example, which is actually example 6. Okay? So example 6 says that some fireworks are fired vertically and their trajectory can be represented by the equation below. Okay, so imagine somebody setting some fireworks up on the ground and they are projected upward. Okay, so once again, their trajectory, right, or their projectile motion can be represented by this equation where the height, or h of t, equals negative 16 t squared plus 80 t. Okay, and then the question is, guys, how long will it take for the fireworks to fall back to the ground? Okay, and we know, guys, that the ground is 0 feet. So ground level is h equals 0. Okay, or h equals 0 feet. Okay, that's ground level. So we already did set 1, guys. We set h as 0, and we're going to set it as 0 in this equation. Okay, so h of t is actually 0, right? Because that's ground level, equals negative 16 t squared plus 80t. Okay, remember, guys, this is the ground. So that's when it hits the ground, okay, at 0. All right, now the second step is, guys, in order for us to find how long it would take for the fireworks to shoot up and to fall back to the ground, we have to use the quadratic formula to find out how long it would take, which is t, right? So what we're going to do is we're going to use the quadratic formula, and it's going to be t equals, okay? And guys, I'm going to use different colors so we can actually see, okay? I'm going to use different colors so we can actually see. So t equals negative b. I'm going to make my b's be purple. Negative b plus or minus the square root of positive b squared minus 4 times a, make a be blue, times a times c, right? All divided by 2 times a. Okay? So once again, guys, that is the quadratic formula. That's the quadratic formula. And once again, guys, a and b are the coefficients, right, that are attached to the t's, and c is the constant, right, that's not attached. That's the y-intercept, okay? So as you can see, guys, we don't have a c, so c equals 0 because there's no y-intercept, right? Okay? A is going to be the coefficient that's attached to t squared, which is negative 16. So a equals negative 16, okay? And b is the coefficient that's attached to t to the first power. So b will be 80. So b is 80. So if positive b is 80, guys, then negative b is negative 80. So remember that, guys. If positive b is 80, negative b is negative 80, okay? So this is our little key, guys, of values that we're gonna plug in into the quadratic formula, okay? So now let's go ahead and plug in these values. Remember, in the quadratic formula, we start off with negative b. Negative b is negative 80. So it's gonna be negative 80 plus or minus the square root of b squared, positive b squared, so it's gonna be a positive 80 to the second power, or squared, right? Minus 4 times 80, right? A is negative 16, so negative 16 goes here. That negative 16 times c, right? And c is, remember, we don't have a y-intercept, so c is 0. So guys, because we're multiplying everything right here, this particular part by 0, you know that anything by 0 equals 0. So I could actually do that to that part, because anything times 0 equals 0. All divided by 2a, and remember a is negative 16. Okay? So once again, guys, the reason why I crossed out this part, because it's going to be negative 4 times negative 15, negative 16, negative 4 times negative 16 times 0. Anything times 0 equals 0. So I can just cross that out, right? So that actually makes the process even quicker. All right? Because now, guys, I have a negative 80 plus or minus the square root of 80 squared. Okay, the square root of 80 squared, and I'm going to talk about that because that's very easy. All right, divided by 2 times negative 16 is negative 32. Okay, so I just want to show y'all something, guys. The square root of 80 squared is actually 80. Okay, because 80 squared is, I believe, 6,400, and the square root of 6,400 is 80. So whenever you have something where it's to the second power, but we are square rooting that, it just equals that number, okay? So this actually just equals 80. Okay? So now, guys, we have negative 80 plus or minus 80 all over negative 32. I'm sorry, I put negative 30. I meant negative 32. I apologize, guys. Negative 32, because 2 times negative 16 is negative 32. So now, guys, I'm going to dissect this problem, okay? If I do negative 80 plus 80, and let's just do that over here. So I got negative 80 plus 80 all over negative 32. Right? Of course, ladies and gentlemen, we know that negative 80 plus 80 is 0, and 0 divided by anything equals 0. And guys, that's true, because it's true that at 0 seconds, the fireworks were on the ground, okay? At 0 seconds, the fireworks were on the ground, okay? So this is true, but this is the starting point, okay? This is the start point. So this is not the answer. Even though this is true, guys, this is not the answer, okay? So this is the starting point, because yes, at 0 seconds, the fireworks were on the ground. But we want to know, after it shot up and did whatever it did in the air and it came back down to the ground, then how many seconds did that take? So on this side, I'm going to do negative 80 minus 80 divided by negative 32. And that's going to give me the time at the end time, right? Or the end point. This is going to give me the end point. So guys, once again, negative 80 minus 80, which is just like saying negative 80 plus negative 80, which is negative 160. So that's negative 160, and if you have a calculator, you can do negative 160 divided by negative 32, which is 5. All right, so the fireworks will hit the ground after 5 seconds. Okay, and this is the end point. So understand the difference, guys. Yes, it's true that at the start point, right, when it was on the ground, that was 0 seconds, of course. But then after it shot up, did its projectile motion, it came back down. The end point was at 5 seconds. So it hit the ground at 5 seconds. All right. So once again, guys, this is the answer. That's the answer, guys. So once again, guys, these are 2 really good examples of how to solve projectile motions, whether they're just asking for the height at a particular time, whether they're asking for the time at a particular height, right? Whether they're asking for the time at the maximum height or the actual maximum height. All of these particular questions, guys, you can solve them from these particular word problems. So thank y'all so much, guys, for tuning in. I will come up with more videos soon.